Good day everyone, I am Sir Philip and welcome to our very first video lesson in physical science where you can learn science concepts in fun and easy way. In this lesson, we are going to discuss about the group of atoms, also known as the molecules, especially its polarity. And now, the objective of the lessons are: at the end of this video lesson, you will able to determine if a molecule is polar or nonpolar given its structure, give the scientific definition of polarity, and identify the molecule's polarity. And now, bago tayo magsimula, meron lamang akong ilang mga tanong. Naranasan mo na ba na mag-urong ng sandamakmak na plato na kung saan sobrang daming sebo at ang gamit mo lamang ay tubig? Walang sabon, walang kahit ano, tubig lamang. Kung hindi mo pa nararanasan, try mo. Ito mangyayari sa'yo. Bakit nga ba hindi kaya ng simpleng tubig lamang na alisin ang mga sebo sa mga plato? Just like oil, grease on the dishes cannot be mixed with water. That's the reason why we cannot wash dishes just simply using water. So parang sa pelikula lang, hindi natin pwedeng paghaluin ang tubig at langis. Now, ano nga ba ang dahilan ng mga ito?
Few moments later.
At ngayon, alamin natin kung ano nga ba ang dahilan kung bakit hindi pwedeng maghalo ang tubig at ang oil. Siyempre, may kinalaman yan sa ating topic ngayon, which is the polarity of molecules. What we're going to do today is to know how to determine the polarity of molecules. Now we have two types of polarity, the polar and nonpolar. So this is how to know or determine the polarity of the molecules. The first step in finding the polarity of the molecule is to find the difference in electronegativity of the elements involved in the bond. Yes, you're right. Magko-compute tayo. What? Pero, ang gagawin lang natin ay to find the difference in the electronegativity of the elements na involved sa bond. Okay? So what we're going to do is to just simply look at our periodic table at hanapin ang electronegativity ng elements na involved. It says here that if the difference in electronegativity is greater than 0.4, it is said to be polar. While if the difference is 0.4 and below, it is said to be non-polar. Okay, let's find out the polarity of some of the molecules using the first step. Let's have carbon dioxide. Carbon dioxide has oxygen and carbon involved in its formation. So just simply looking at the periodic table, oxygen has 3.44 electronegativity, while carbon has 2.55. So just simply subtracting the two, 3.44 minus 2.55 is equals to 0.89. In this case, since the electronegativity is greater than 0.4, carbon dioxide is said to be polar. The second step in finding the polarity of the molecule is through Lewis dot structure. Lewis structure shows us the element, type of bond, and the valence electron. Now, what is important here is the central atom. It says here that if the central atom has no lone pairs, the molecule is considered to be nonpolar. And if the central atom has lone pairs, the molecule is considered to be polar. So, ang titignan lang natin ay ang central atom. Now, what is lone pairs or lone pair? Lone pair in chemistry are the valence electron that is not involved in sharing or in bonding. Okay, let's find out the polarity of the carbon dioxide using the second step. This is the Lewis structure for carbon dioxide. Just simply looking at the central atom, we can see that there is no lone pairs. Again, if there is no lone pair involved in the central atom, it is said to be non-polar. Ano ba talaga? The third step in finding the polarity of the molecule is through the geometry of the molecule. Geometry of the molecule is simply the shape of the molecule. It says here that if the geometry of the molecule shows symmetry, the molecule is said to be non-polar. While if the geometry of the molecule shows asymmetry, the molecule is polar. Okay, let's use it in carbon dioxide molecule. As we can see in the structure and as we divide it into two, both sides has equal part. So in this case, the geometry shows that the molecule is symmetrical. So the final judgment for the carbon dioxide molecule is that it is a non-polar molecule. And that's it. Using those three ways, we determined that carbon dioxide is a non-polar molecule.
2,000 years later.
And now, let's find out what is the polarity of the most popular molecule in the world. And that is water. Okay, let's find out. Okay, let's determine the polarity of water using the third way. We have here the shape of water molecule and Lewis structure. Either of the two can be used using the third way. As we divide them into two, the structure shows symmetry. Therefore, water is nonpolar in this case. How about in second way? So we have here the Lewis structure of water. The central atom, which is the oxygen, has lone pairs of electrons that were not paired with other electrons of other elements. In this case, water is a polar molecule. So, ano ba talaga? To make it clear, let's have the first way. Water has oxygen and hydrogen with 3.44 and 2.20 electronegativity respectively, and the difference is equal to 1.24. Since the difference is higher than 0.4, water in this case is a polar molecule.
6.5 hours later.
So ayan dahil dyan, nalaman na natin na ang water ay isang uri ng polar molecule. That's the reason kung bakit kapag tayo ay nag-urong ng sandamakmak na plato na punong-puno ng sebo, ay hindi natin kayang urungan. Okay? Because in chemistry, polar molecule likely dissolves polar molecule only. And vice versa, non-polar molecule likely dissolves non-polar molecule. Water is a polar molecule at ang oil or yung sebo ay non-polar molecule. So, para mahugasan natin yung plato na puno-puno ng sebo, kailangan natin ng something na meron ding non-polar molecule, which is present siya sa mga dishwashing liquid.
Kuya, magsayang na daw.
Teka naman kasi nag-uurong pa eh. Nagbibideo kami dito eh.
2,000 years later.
We are done determining the polarity of water and carbon dioxide. So before we proceed to our short quiz, let's do more examples. We have here CH4, or also known as the methane. Methane has carbon and hydrogen on its formula. So we have carbon with 2.55 electronegativity and hydrogen with 2.20 electronegativity. So the electronegativity difference is 0.35. So therefore, yes, you're right. It is non-polar. For the second way, we have here the loose structure of methane or CH4, and it shows that there is no lone pairs on the central atom. Therefore, CH4 or methane here is non-polar. For the third way, using the Lewis dot structure also, we can see that it has a symmetry. So therefore, CH4 is also a non-polar molecule. Let's have another one, which is sulfur dioxide. Sulfur dioxide has sulfur and oxygen on its molecular formula. Sulfur has 2.58 electronegativity, while oxygen has 3.44 electronegativity. Their electronegativity difference is 0.86. It is higher than 0.4, therefore, sulfur dioxide is a polar molecule. For the second way, we have here the Lewis dot structure of sulfur dioxide, and as we can see, the central atom is sulfur and has lone pairs. If it has lone pair, yes, you're right, it is a polar molecule. For the third way, as we use the Lewis dot structure of sulfur dioxide, it shows also symmetry. Therefore, in this case, sulfur dioxide is non-polar molecule. So our final judgment here is sulfur dioxide is a polar molecule. And that's it. I'm done with my part, so it's time to do yours. Kumuha na ng isang papel, kumuha na rin ng isang ballpen, then sagutan ng mga sumusunod.
No! God, please, no! No! No!
Okay, using the 3 steps, find the polarity of the following molecules: ammonia, sulfur dioxide, carbon tetrachloride, chlorine gas, and hydrogen sulfide. And that's it. Thank you everyone for watching. I hope you learned a lot from me today. So see you on our next video. Bye.